In this chapter, we're going to be looking at sorting and searching algorithms. And in this first lesson, we're going to start with one of the simplest sorting algorithms, the insertion sort. What you're looking at on your screen right now is an animation from Wikipedia that demonstrates how the insertion sort works. Essentially what we do is that we check each element as we come across it and then put it in the correct place in the order, so that when we're finished going through the array of numbers, in this case, we'll have a sorted list or sorted array. Now the insertion sort is not particularly efficient, and I wouldn't suggest using it on anything other than a small set of data. But for a small set of data, under 1,000 items or so, it's fairly fast. Now let's see how to create the insertion sort algorithm. Let me delete any old ones that I may have. So we're going to call our program insertion sort.java. All right, we're ready to start. First thing we're going to do is set the size of our array, which we're going to keep it small so it'll be easy to see what's happening. After we've set the size, we'll declare an array of that size. Then we'll initialize it by writing a simple for loop and assign each element of the array a random number in the range of 0 through 100. So that's what I'm doing right here. After we've initialized the array, next thing we'll do is display the array so that we can see what the data looks like before it's sorted. So we'll call this before sorting. Essentially, this is the very same loop. So what I'm going to do is I'm going to copy and paste, and then we'll just modify it a little bit. Just like so. The next step then is to begin the sorting algorithm. So I'll skip a space so it's clear to see what's going on there. So we start out with an outer loop that runs from the first element of the array through the end of the array. Then we have an inner loop that begins at whatever value of I we are on, runs while j is greater than 0, and we decrement each iteration of j. Now we do a comparison. And then we say if the value of data sub j minus 1 is greater than data sub j, then we want to swap those elements. So we create a temporary variable, temp, and we're going to do a swap. And then data j is equal to data j minus 1. And data j minus 1 is equal to temp, like so. Then close the if. Close the inner for. Close the outer for. Print a blank line. And we'll do an after sorting. And then we'll use this loop right here to print out the results of our sorted array. It's like so. Close main, then close the class. So let's see how it works. Save. Come back to our command prompt. Compile. So you see we have 88, 53, 80, 0, 50, 47, 95, 39, and 2 40s. And we have 0, 39, 40, 40, 47, 50, 53, 80, 88, and 95. Let's run it again. We see we still go from a unsorted to a sorted array. Let's do it one more time. Again, we're looking at the bottom here, and you'll see that the sorting algorithm works just fine. So again, this is a very easy algorithm to implement. It's easy to understand, but it's inefficient for larger data sets. And later on in the chapter, we'll look at an algorithm or two that are much better for large data sets. But for now, we're going to move to the second sorting algorithm in this chapter, another one that's easy to implement but not all that efficient, and that's the bubble sort.